Copeland Corporation, a division of Emerson Climate Technologies, is introducing advanced scroll temperature protection, a breakthrough development in internal discharge temperature protection on its 7 to 12 horsepower commercial scroll compressor platform. With advanced scroll temperature protection, the compressor's scroll elements actually unload, stopping compression when high temperatures are observed. The technology is completely internal, meaning there are no wires or sensors to deal with, and the device cannot be bypassed, a common cause of failure in compressors with external protection schemes. Advanced scroll temperature protection is made possible by the unique design of Copeland scrolls. In normal operation, compression forces try to push the upper and lower scroll elements apart. Copeland scrolls use a pressurized cavity on top of the upper scroll in order to provide just the right amount of hold-down force to keep the scrolls together. In compressors with advanced scroll temperature protection, a bypass hole has been added between this cavity and the suction side of the compressor. A bimetal snap-acting thermal disc blocks this opening, similar to a valve. When this disc senses excessive temperature, it snaps open and allows the pressure in the cavity to escape to the suction side of the compressor. As the cavity pressure drops, the hold-down force on the upper scroll is eliminated, allowing the scrolls to separate. This stops compression and allows internal temperatures to decrease, although the motor continues to run. In other words, the compressor will run, but will not compress gas. Suction and discharge pressures will balance. To reset the thermal disc, stop the compressor and allow it to cool thoroughly. If the compressor is allowed to run, heat will build up in the motor, causing the compressor to shut down on motor protection. Keep in mind that the longer the compressor is allowed to run unloaded, the longer it will need to cool in order to reset. If you find a compressor that is running but not pumping, it is likely that advanced scroll temperature protection has activated. Do not assume the compressor has failed. Turn off the compressor and allow it to cool thoroughly, which may take a half to 2 hours. Then restart the compressor and verify that it is operating normally. In this example, watch as the internal temperature reaches 275 degrees Fahrenheit. The bimetal disc will snap open and the compressor will unload. Note that the pressures have balanced and the internal temperature is now decreasing. This unloaded condition will continue until the compressor is stopped and allowed to cool. Because it is internal, automatic, and cannot be bypassed, advanced scroll temperature protection will prevent compressor overheat failures that are often the result of system malfunctions, low suction pressures, or misapplied temperature protection systems. Remember, a compressor that is running but not pumping suggests a protected compressor, not a failed one. Look for the Advanced Scroll Temperature Protection label to determine if the system you're servicing has this internal protection technology. For more details, visit us on the web.
Efficiency, reliability, flexibility. All key components of refrigeration. Emerson Climate Technologies introduces the Copeland Scroll Outdoor Condensing Unit. Ideally suited for walk-in cooler and freezer applications, the small footprint, low noise, and energy efficiency make it a perfect fit for restaurants and convenience stores. By using scroll technology, variable speed fan motors, and large capacity condenser coils, the Copeland Scroll Outdoor Condensing Unit will save more than $350 in annual energy costs. This video is designed to show you the necessary steps to install and prepare the unit for operation. In any scenario, it is important to make sure that you have the correct information and tools to complete the job. To install the Copeland Scroll Outdoor Condensing Unit, it is recommended you have a straight slot and Phillips screwdriver, Allen wrench set, adjustable crescent wrench, channel locks, wire stripper, torch brazing kit, brazing material, refrigeration gauge set, heat shield, volt ohm meter, deburring tool, emery cloth, safety glasses, evacuation equipment, and nitrogen cylinder with pressure regulator. It is very important that you have the supplied installation manual and a current detailed wiring diagram for the equipment that you are working on. Please keep in mind that each installation is unique and that this video is a basic overview in a controlled environment. If you have any questions, please contact an Emerson technical specialist or visit our website at emersonclimate.com/Copeland Outdoor Unit for additional support information and our toll-free technical support hotline. Refer to page 5 of the installation manual for location placement consideration and requirements. Once the unit has been installed in the desired location, the next step is to connect the tubing. Start by removing the process caps on the liquid and suction service valves. Next, remove the plastic caps from the suction and liquid service valves. Using the appropriate Allen wrench key, mid-seat the valves. It is important to stay clear of the face because when you open the valves, the N2 charge will be released, which is 8 to 10 pounds. The correct tubing is 1/2 inch for the liquid line and 3/4 inch for the suction line. Prepare the tubes by deburring the field tubes, making sure to keep all debris out of the tubing. Clean the tube with an abrasive material, like a crocus cloth. Make sure to clean the copper tubing on the unit as well. This will ensure that the copper tubing is free of dirt and oil. Next, insert the tubes in their proper locations. Before brazing the tubes, it is important to wrap a cold, wet rag around the valves to provide a heat sink to avoid damage to the valve seals. It is also important to use a heat shield, such as a piece of tin, to keep the paint from being burned on the unit, which will prevent rusting. Now braze the tubes according to your brazing procedures. Now that the brazing is complete, the next step in the installation process is to check the equipment for leaks. It is important to check the receiver valve to verify that the valve is open. To do this, remove the front panel. There are 6 Phillips head screws holding the panel on. Prior to the leak check, with the panel off, verify that the receiver valve is open. The valve is open from the factory, but it is recommended to double check. It is good refrigeration practice to use nitrogen gas for the leak check. Remove the process port caps on the service valves. Connect the hoses to the service valves. Open your nitrogen tank supply and set your regulator to your company's standard leak check practices. With the leak check complete, it is now time to perform a system evacuation. The vacuum you will want to achieve is based on your standard service practices. Hook the vacuum hoses to the service valve's process ports. Open the valves, turn your vacuum system on, and perform the system evacuation according to your company standard. Once you have determined that the evacuation is complete, close both service valves and remove the hoses. At this time, the refrigerant charge can be supplied to the unit. Note, prior to energizing any electrical power to the system, a holding charge must be applied to the liquid line of the system. At this time, the service valves are both closed. Once you set your refrigerant cylinder and your gauges, open the liquid line valve to allow the charge to enter your system. You will charge 2 to 3 pounds of refrigerant into the unit, depending on the size of the system. Now energize the system and adjust the system charge using standard refrigeration practices. Depending on your application, you will need to address defrost. A medium temperature application typically does not require a unit supplied defrost scenario. Follow your standard defrost practices that you employed on your previous application. If you're using a low temp application, you will need a defrost solution. The Copeland condensing unit does supply a defrost module, which will need to be wired according to the unit supplied wiring diagram. If you choose to use the customer supplied defrost, you will remove the defrost cable, located here in the electrical enclosure. Next, change the dip switch settings in accordance to the supplied user manual. You will then proceed with your routine defrost timer installation procedure. Finally, manually adjust your low pressure control to adjust your low pressure setting. When utilizing the Emerson supplied defrost module, you will need to run 2 wires. One from terminal point 12 on the terminal block to JP10 on the control board. This controls the evaporator defrost heater. The second wire will run from JP9 on the control board to the evaporator section or wherever the relays are mounted to switch the defrost heaters and fans. Reference Figure 4, page 10, and the wiring diagrams in the back of the manual. Once the wiring is complete, you will need to adjust the defrost module. To set the defrost duration and time intervals, you will use a screwdriver to set the clocks accordingly, using Table 4 in the user's manual. Finally, with these steps complete, we can now install the electrical components in the unit. Remove the necessary knockouts to install your electrical components. Feed the power wires into the unit. Take the conductors, which will be sized to the National Electrical Code, and mount them to the power board supplied inside the unit. The unit is now ready to be energized. In any instance that you might need the model number, serial number, voltage requirements, or any similar information, you can find it on the side panel of the unit. If you have any questions regarding the condensing unit, contact 888-367-9950 for technical support, or contact an Emerson technical specialist at your local Emerson full line or authorized Copeland branch. As stated earlier, this is a basic overview of the steps to complete the installation. Please be aware that each customer situation has its own unique requirements. Be sure to consult the wiring diagram, the user manual, and if necessary, an Emerson technical specialist. To learn more about system setup and troubleshooting, please view the Diagnostics Made Easy video. Thanks for watching.
One of the most exciting product introductions in New Calgon's history is AC Easy Seal, a product that can be used to repair or prevent refrigerant leaks in air conditioning or refrigeration equipment. It utilizes innovative technology that enables the sealant to travel with the system refrigerant, finding and repairing leaks quickly and efficiently. Today, we have Dave Fantle, who has been an HVACR technician and has operated his own business for over 30 years. His current project involves a 24,000 BTU Larkin coil from 1978 at a bakery in Summit, New Jersey. The walk-in freezer cannot be down for more than 3 to 4 hours to maintain the inventory of the refrigeration unit. Dave used AC Easy Seal from New Calgon and was able to save the bakery time and money.
This is a Larkin 1978 24,000 BTU coil for minus 10 below zero. Up on the roof is a 5 horsepower condensing unit. If Easy Seal was not invented by New Calgon, I would have had to have changed this coil, which would have probably cost roughly $8,000 with time and labor. As you notice, this threaded rod through the ceiling, along with probably being down for 1 if not 2 days. And if you have a customer here that cannot be down for more than 3 hours when you're a bakery and you have a lot of frozen products. Therefore, I put in the Easy Seal back in November, and ever since then, it has been full of Freon and it has worked. Here we have a Larkin coil, 6-fan freezer coil. Back over here, behind the support bracket, which holds the tubing together when they made the coil, up in this area, I'm going to shine my light. In this spot where I moved the fins out of the way and the bracket, approximately 4 inches in, was where the leak is. Now I say to myself, do I try and solder on something that probably is leaking on the opposite side of the pipe that I cannot see after I used bubbles, okay, or fluorescent bubble juice, which bubbles when you see the leak, or do I try Easy Seal? Well, I tried the Easy Seal, and again, like I said, since November, this system is still full of gas. As you can see here, I bent the bracket away and I moved some of the fins out of the way just to see and make sure that that's where the leak was. And the leak is so big that if you were to put your ear approximately in this spot, you will actually hear the leak before I put the Easy Seal in. That's how big the leak was. And the Easy Seal has prevented it from leaking ever since.
AC Easy Seal has been engineered to travel through a refrigeration or air conditioning system with the refrigerant, allowing it to find leaks faster and using less sealant than competitive products. It works with all refrigerants, and because AC Easy Seal is in a pressurized can, it is easily injected into any air conditioning or refrigeration system in just 2 minutes, saving the contractor time and money. For more information on AC Easy Seal, please visit us on the web at newcalgon.com.